Everybody, lots of people gone today for choir and other things. So let me go ahead and get started with our notes today. First things first, you will need your chapter 2 notes. So please don't watch this video and just watch it. You need to take notes. You are responsible for the information in this video. So please make sure that you take your notes. Second announcement is I want to make sure that if you have not submitted your scientific argument, that you take the time right now to do so. All right, let's get started. So yesterday, you mixed 2 different substances together in order to test your hypothesis regarding the investigation question. The investigation question, if you remember looking on your notes, we're asking, can a substance change into another substance? Is it possible for one substance to become another substance? And you made a hypothesis, either yes or no, and now we are testing your hypothesis. We're making some observations using the macro scale. We're using our naked eye. And so let's go ahead and talk about that. What evidence did you observe that supports your claim? So first of all, did you think that the substances changed into different substances? Do you think that the substances did not change into different substances? Or are you not sure? Hopefully, you said that the substances did change into something different. So it's that very first one. And then the evidence that we observed to support our claim. You should go back in your notes and you need to take a look at the observations that you made from the product and compare those to what the reactants were, or the 2 substances that we had beforehand. The very easiest thing to say is before they were a liquid. They were dissolved in a liquid. And so they were in liquid form. And the product was a solid. You can talk about the different colors. Be specific here. In your notes, I've given you a place to write down what evidence did you observe that supports your claim. And I guess the thing I want to ask is, we're pretty sure, according to key concept number 1, we do have some different substances that have different properties. I'm sorry, the end product has different properties. So we're pretty sure that that's a different substance. What's the one thing that we were not able to observe? I'll give you a clue. We can't see it. It's way too small. Yep, we were not able to observe the molecules during that chemical reaction. If we were able to observe the molecules, that would actually make our argument stronger, because we could see that they started out as one kind of molecule and they turned into something else. Well, lucky for you, we're going to go into the sim. And let me show you, this is the directions. I'm going to keep that kind of right there. I'm going to go into the sim. I know a couple of you guys told me that you're not going to have access to your iPad, and so I'm going to go ahead and do the sim for you. If you would like to work this on your own later on, I encourage you to do so. But I'm going to just show it to you so I know that I can talk you through it. And I don't know why I did that. I want to do the chemical reactions. There we go. All right, we're going to start off by clicking on these 3 lines. We're going to be in laboratory A, which is the default, so I'm good there. We're going to add a substance. Now, in the directions, we want to copy or what's the word I'm looking for? I want to simulate the experiment that we did yesterday. So I am looking for calcium chloride and I'm looking for sodium carbonate. Okay, so I'm going to add the first substance and I'm going to do calcium chloride right here. And then I'm going to add another substance, and that was the sodium carbonate right here, Na2CO3. So in this, we're going to go ahead and we're going to hit the test button. And I'm going to come back to my directions. And it says press test, then press results, examine the results, press review, and compare the substances at the start and the end of the test. And then last thing is I'm going to turn on the atomic scale and view the property toggles. And then that's my evidence that I can use to decide whether or not a chemical reaction actually did occur. So here we go. I'm going to go ahead and test. It's going to put this into basically a little simulator. And here's the cool thing. I can take this button, I can back it up, and I want to talk to you about what you see. So I see this molecule. It's one molecule of sodium. Actually, it's Na. Oh, do I have the wrong one? Oh, boo. I do. Calcium chloride, Na2, CO3. Oh, yeah, this is right. Sodium carbonate and calcium chloride. Yes, that's it. Perfect. I can use this toggle button and I can go real slow. And here's what happens. These molecules are just moving around happy as can be. And then we combined them. We poured the two substances together in a cup and they touched. And look what happens when they hit each other. What happens to the atoms? They break apart and they reconnect, they rearrange. And I've got another calcium or sodium that needs to get back to that. There we go. And now I have these two new substances. The first one is NaCl, and the second one is CaCO3. So I'm going to go over here to my results. It's going to identify it for me. And it says that NaCl is sodium chloride, also known as table salt. So do you remember when you were feeling it? And you may not have been able to feel it very good in your gloves, but it started out feeling kind of gritty. It was table salt. And then by continuing to kind of rub it together, you were basically kind of breaking it apart. And the other one is CaCO3, calcium carbonate. It's chalk. So we made table salt and chalk, two completely innocuous, not dangerous substances that are very common. But this is what we get when we have this chemical reaction. So let's go ahead and hit, did I say I wanted to hit the review? Yes. This gives me my chemical formula. So I can see my before, here's my little arrow that shows that there was a chemical reaction. On the left side of the arrow, I have my two reactants. And on the right side of my arrow, I have my two products. And if I want to, I can view my properties and I can turn on my atomic scales and I can look to see this is what's going on. How cool is that? So I can see based on the properties that they are different properties because they are different substances, because they're made up of different molecular molecules. I don't know why I couldn't think of that. One thing you might notice that the calcium chloride and sodium carbonate at the beginning of our chemical formula, or on the left side of the arrow, the reactants, you may notice that they're solids at room temperature. Remember, they are. I told you that. We just could not do anything with them as a solid. So they were dissolved in water. So I know that we said that they were liquids, and technically they were a part of the liquid. They were dissolved in the liquid, but we're going to identify them just at room temperature without the water. Okay, so that's why they are a solid. Okay, let's come back to your notes. So now I'm going to have you, in your notes, I asked what happened when you, actually I think in your notes it's just open, and I want you to describe what happened in the sim. So think about what happened when you mix the two substances together, and then you can explain your answer using evidence from the sim. So look at what I have on my screen, and then in your notes on the right-hand side, I think it's the one that has, hang on, let me find it. It's this one right here. This one, the SIM atomic model. It says student answers may vary. They should explain what happened to the atoms and the molecules when they were combined. So talk to me about that. And if you need to do it yourself so that you can kind of explain it a little better, or go back and watch the video again so you can break it down, remember step by step what happened first, what happened second, explain what happens. Okay. So now let's go back to our investigation question, which is it possible for one substance to become another substance? Using evidence from our hands-on activity in our sim, we're supposed to write a scientific argument. We're not going to do that. We can just talk about it. The answer is absolutely yes. Absolutely yes. I had the kids share that information in class. And then we've got a couple vocab terms. First one is reactant. A reactant is a starting substance that's part of a chemical reaction. And remember, this is what's on the left side of the arrow. So in this situation, we had two reactants. And then the next word is product. The product is an ending substance that's made during a chemical reaction. This is on the right side of the arrow. And in this situation, we had two products. We had salt, NaCl, sodium chloride, and we had calcium carbonate, which is chalk. I've got a diagram for you that shows you the reactants and the products. Notice I've got an arrow in between. So you can say on the left side of the arrow, I've got my reactants. Look down at the bottom of that box. It's labeled reactants. And then my products on the right side of the arrow. And you can tell, key concept number 3 says, substances have different properties because they're made of different groups of atoms. Different groups of molecules. Okay? So the atoms broke apart, they rearranged, and formed a new substance. Okay? Last thing is key concept number 5. During a chemical reaction, one or more starting substances, the reactants, change into one or more different substances called the products. Okay. Now, the rest of class time, if we had any class time left, I just let the kids study their key concepts and their vocab. Your homework is to study your vocab and your key concepts, okay? By this time, you should have all of your vocab and key concepts from chapter 1 memorized, and start working on key concepts and vocab from chapter 2. All right, you guys, I'll see you tomorrow.